Hey, welcome back to BackBit Impawsible. I'm Loop Dark Snout, and wow, rainbow. Ha! I remember taking this picture. I'm on the highway in Saskatchewan here, and I pulled over to do it. Anyways, yeah, what am I going to tell you? Oh yeah. This is a quick episode here. I wanted to see where on the original bitmaps the characters that become part of the character set, where are they sourced from? Where does it get them? So with a bit of hack, a bit of extra code, I made those characters show themselves. So take a look. You'll hopefully gain an appreciation, like I did, as to how these programs work under the hood, because the results are kind of clouded, and this helps bring them to light. Anyway, yes, and well, I got something else to say, but I'll hold off for now. Anyway, let's get to the clips. I add a little bit of code in here, so as you can see, all the little Spazz Out Squares, these are where the 256 cells that generate the image are coming from. Well, what I'm glad to see here is that they are even somewhat spaced out. Like every section of the photo has something important to contribute. I want to try this code with other frames and see what it looks like. It makes sense that my other idea where I divided subsection, like grid, and choose the best one from it, may not work very well, because like, look at this little square here. If I divided the screen into 25 and it's got to pick something awesome from there, it's not going to find something awesome from there, but it'll force it to do it anyway, place it wherever it fits in the entire screen, and eventually it all gets written over with better ideas anyway. So I don't know if this is the absolute best. Oh, and I don't know how to get out of here. I didn't make that code. Oh wait, what's this button? There we go. And then this one. There we are. Yes. Interesting. 6979. It shouldn't be. And here we go. Well, I knew the interior of his body had a lot of repeated stuff. That's why this particular frame is so efficient. The tree is sure gobbling up a lot of characters too. Interesting. Just wherever a unique pattern is found. And this here is frame 0. Yeah, another interesting frame. Well, I'm glad some of the details, like the smile or whatever, got included. But now let's see what the rest of it is. Now I realized the global mismatch is because it's now comparing to the gibberish squares to the actual picture, so that's always going to be out. Okay, I'm using a Character Maker 2.1, which whittles away it merges them. But anyway, I'm still not satisfied with the program. It's not fast enough. I'm running it at 20 megahertz. That's great, but okay, now here's the trick. Now I'll slow it down, but I put in a little hack here that's going to show me where character 0 begins, like the first occurrence of character 0, character 1, character 2. And I've noticed, because I wrote this thing, they do appear like I expect them to, in order. And here they are. So these are the first appearance of each of the 256 characters. And yeah, it's kind of neat. And, well, another frame that I've already tried this for. Let me look at my sheet here. 102, version 2.1. This should be done in about 31 seconds. And it leaves 2,635 pixels. Whereas I get 2,300 if I end up spending 35 minutes. Youch. Okay, so there we go. And let's take a look at our characters. Boop-a-doo. Kind of neat. I find this fascinating. I'm sorry I keep showing it. Okay, this time around I optimized it a bit. It's going to print a character and then fill the screen with every occurrence of that character and then move on to the next. But you'll see a lot of the beginning characters are unique. Look at that. It's not for a while. Well, there's a few until we get to the M and the N that there's many of them. Neat. And of course, each one of these super repeated characters help knock down the original 1000 cells to a manageable 256. This is how this compression works. It basically has to whittle it down from 1000. And by doing that, it finds the best way to share certain cells. That's kind of neat. And this is it, all 256 characters, starting with this guy. It's kind of neat that this one doesn't automatically become. And down here, there's 255. Now, take a look at this. Okay, here's the part that I was itching to tell you about. You see, the characters that Character Maker 2.1 comes up with are listed sequentially here. Why is that? And even though I wrote this code, a year ago, I forgot how it works. Basically, these are the 256 cells that remain from the initial 1000. And they're sequential because it's not until you're down to 256 does the pass go by where it actually gathers them up into a character set. And that's why they're sequential like this. So after we have that, we have to create the screen, create the video matrix using those characters. So we start with a video matrix that's basically a blank slate. The pixel difference for every cell in this video matrix is starting with a default value of 33. That's because no matter what you feed it, no matter what you compare against it, even a gibberish square is going to have a pixel difference of 32. So the very first thing you compare it with is going to be better than what's there, and it becomes screen wide. And that's why, as you see, I'm going to play this back really slowly here. The very first character that you're using, character 0, is happily put down screen wide. And then it moves on to character 1. And it tries to put it everywhere. And if it's better than what character 0 provided, it takes that place in that cell. And then character 2, character 3, and so on. And that's why you can see the image build itself, because it puts down the current best for that particular spot on the video matrix. And it keeps revising it because it comes up with a better one, goes, oh, hey, this is better than this. So it tosses that and writes over it. And it does this repeatedly, quickly though. And that's how you wind up with such an interesting pattern. The way it draws the screen is kind of cool to watch. And it's basically refining itself. It doesn't find the perfect fit. It just keeps trying each puzzle piece until it finds the best fit. And when all 255 have been, or 256 have been tested, the screen is done. The character set is established. The video matrix is locked in. You're done. Wrap it up. Boom, done. And that's cool. I really like this. But this afternoon, I was actually thinking about this, how Character Maker 2.1 works. And actually, I might have improved upon it in my head here, which is kind of dangerous at this point because I'm done the project. There's no way I'm digging this open again and possibly changing how things work. But if I do come up with a better solution that I've already come up with down the road, I'll let you know. But until then, yeah, that's the end of this video. That's a short one, isn't it? It's not the first time I've heard that. Anyway, yeah, next video, we're back to the regular length. However, it took, 8 months to make the next one. You'll see why soon. Anyway, till then, I'm Luke Darksnow.